All right. So for this section, we're in 4.2. We're looking at polynomial functions. So in particular, we're going to look at the graphs, and so we're going to talk about what's called end behavior. This is something you would have probably talked about in integrated math 3. What are the characteristics of polynomials, and what are extrema, x-intercepts? I know you know what those are. Hopefully we'll get the average rate of change in this lesson. If not, we'll add it with piecewise on Wednesday. So our goal. So I made up, this is a polynomial, and for instance, this will be a 4th degree. So the first thing we're going to talk about with polynomials is, what is a polynomial? Well, what you're going to notice are the exponents are whole numbers. So you can't have square roots or absolute value or anything like that for polynomials. So the exponents are whole numbers, 0, 1, 2, 3, 4. And the highest exponent is the degree. So for instance, on this problem here, our goal for today is to be able to work that. This would be a 4th degree polynomial. And there's something about the degree that tells us certain aspects of the graph. So it's important to know the degree. So I have 4 polynomials that you're going to graph. So our first objective is to go through example 1. You're going to graph all of those on your calculator. You can either graph them separately or you can graph them all in one window. And I'm just asking you to look to see what's the same. So I'm going to point to each one. You're going to tell me the degree. So for part A, what's the degree? 2nd degree, 2. Part B, that's fine. Degree is 4. Part C, 6. Part D, 8. Now, sometimes they'll write it out of order. Typically, we put it in descending order. So from highest exponent to lowest exponent. Okay? Now, so go ahead and just grab your calculator, graph each one of these and see what is it that is the same for each. Okay, so what's the same for each one? And see if you can figure that out. Yeah. Take more of a broader view than a specific view. As I'm going to tell you right now, you're going to need a calculator for this section. It's required for this class. If you do not have a calculator, it's going to be difficult for you to complete this section. You could get away with putting all 4 on one picture. That's why I listed them Y1, Y2, Y3, Y4. You just put them all on one graph. I would probably do a zoom 6, standard zoom. All right. So what looks the same? What do you notice about every graph? What's that?
Is it like the origin? Like where they
No, not all of them. They don't all go through the origin. That's not what's the same.
Just taking right away.
So you need to take more of a broad view than a specific view.
They're all parabola shape.
Well, be careful, parabola is just this. Yeah, but you're on the right track. But what else can you say? They're not all parabolas, but what do they all do?
They all have like reviews
Okay, what else? There's something that they all do that's the same. So as you go left, where do they all go? No? As you go left, where do they all go? Look at the picture. Up. As you go right, where do they all go? This is what they all do that's the same. They all do that. Every one of them. Every one of them, as you go left, they go up, and as you go right, they go up. They all do different things down here. Some, of course, the x squared just bottoms out at 0, but they do different things in here. But one thing they all do is as you go left, they go up, they go right. You go right, they go up. That's called the end behavior. So the end behavior for all of those that we gave you are the same. So now, go back to each one. Did you put them all y1, y2, y3, y4? So now go in front and put a negative in front of each one and see what happens. Put a negative in front of each and see what you see there. Calculator not working?
I must have did something on the graph, it busted it, it just keeps showing something.
It's gonna flip it, so they're all gonna be down.
Well, it doesn't flip everything. I'd have to negate everything to flip it, but yeah, just see what you. No, just put the calculator down. Is it on?
Yeah.
Hit white. The calculator's not even on, it's dead.
No,
I don't see
I can
anything.
see like these little pixels.
Hit second. Yeah, hit the up arrow, second up. Second up again. Again. Keep going. Alright, now. Just hit enter. Enter down at the bottom. Second, maybe on. Trying to get it to stop. Second enter, try second. Hit stop.
I think so.
No little way. No, turn your plot one off. Go up to plot one. Hit enter. Now, go back now, hit graph.
Oh, yeah, I have to remember it. I know, so that's.
Do zoom. Do the same thing, try the second enter. Do zoom 6. Yeah. Yeah.
Thank you.
Okay, so what do you notice about all of them when we put a negative in front? They all do what? They all go down. Okay. What on each of those graphs there, what is something that, not the picture, but what's something that all the equations have in common? They have to because they're polynomials. What specifically about the exponents? What was the degree of the first one? 2. What's the degree of the second one?
4.
What's the degree of the third one?
6.
What's the degree of the last one?
8.
8. What do you notice about the degree? They're all even numbers. So even degree either opens up, up, or opens down, down. So what we're going to do is we're going to list some more specifics now. So on end behavior, and so let's just say our polynomial is ax to the m plus dot, dot, dot. Where this is that first term that we're looking at, because that's what it tells us. So let me make it ax to the n, sorry. So n is the highest exponent, which is the degree. If n is even, so we've been looking at if all the degrees are even. So basically, here's what I want you to do. The reason I did this basic one is that, look, if the degree is even, it's gonna relate back to x squared. It's gonna do similarly to what x squared does. So if the degree is even, if a is greater than 0, the graph does this. Goes up to the left, up to the right. The technical term for this is x goes to infinity, y goes to infinity. That's how you say up to the right, because that's infinity in the x, that's infinity in the y. This one would be x goes to negative infinity, because that's left, y goes to infinity. Right? And if a is less than 0, so the number in front, okay, it's negative. We saw that it went down like this. X goes to infinity, y goes to negative infinity, x goes to negative infinity, y goes to negative. And that's always going to happen. Okay, so the largest exponent in that term tells you the end behavior. Okay. So if I did a part E without you graphing it, y equals negative 4x to the 10th minus 7x cubed plus 2. Can you tell me the end behavior?
Yes.
Which way? Down? Both are down, right? Left down, right down. So just to draw it real quick, you know it's going to do this. You're looking at the first term, if it's even. So what I always do is I think if it's even, it's like a negative x squared. What would negative x squared do? So it does the same thing that does. Okay? So relate it back to that. All right. What are we missing? What have we left off? Even degree, positive in front. Even degree, negative in front. Yeah, odd. So now, instead of, we're not going to graph all of these, but what I'm going to do is at least link them. So let me go over here. So first of all, x cubed. This is considered a polynomial. What would the degree of this be? Third degree. What does the graph do? Just say x cubed. Yeah. So it goes down to the left and up to the right. So all of the odd degrees with a positive front are going to do the same as this. So like, let's say I had 2x to the 5th minus 4x cubed plus 3x squared minus 2x plus 1. You're going to focus in on this, and you're going to see that since it's a positive x to an odd, it's going to do the same as a positive x cubed. So what I mean by that is the way this graph is going to look, it's going to go to the right up and to the left down, just like an x cubed would. Okay? Everybody understand what I'm relating this to? Because it's an odd and it's positive, it's going to look like this graph. So instead of doing 4 or 5 separate graphs on your calculator, I'm just kind of getting to the point of what the shortcut is. So this graph, even though there's a lot going on with it, since it's an odd degree and a positive, it's going to be similar to x cubed. It's probably going to do different stuff in here, but it's going to go up, right, down, left. Okay? All right, the last one, kind of running low on room. Let's say I had this. So what does negative x cubed look like? What does that graph look like?
Left and up, and then down.
Yeah, it's just a flip, right? So it looks like this. So its end behavior is left up, right down. So any odd with a negative in front, let's say we had like negative 2x to the 7th plus 3x squared, right? You could type that in quickly if you wanted. What I do know is it's going to go left up and right down, because if it's odd and negative, it's going to relate back to this graph. Okay? So we'll summarize this right here. I'm going to need to erase some of this stuff. Okay? So I'm going to put it right here. Erase this. So if n is odd, so if it's an odd degree. Odd degree. If A is greater than 0, so positive in front, it goes up, right, down, left. If A is less than 0, it goes up, left, down. That's it. Those are the 4 situations that you, I didn't put all the X to infinity, Y to infinity, you can see all that. Okay? So our goal, we should at least be able to do part A now. Okay? You can do part A. All right. Now, so what I need to do next is go through, oh, what's the degree of that last polynomial that I put on the board? What's the degree of this one? 7th degree. You usually put like not a 7, but like a 7. Yeah, okay. So the next thing I need to do is give you, so every one of these graphs that we put on the board today, they're all polynomials, and they all have something, some things in common. So we're gonna list that. So let me, I'm gonna leave this here for another second or two, then I need to erase all this so I can write. So you have almost this done. This is what's gonna, your chart for end behavior. You're gonna need that, all right? Almost got it? Yes? No? You got it? Everybody else? Good? Okay, all right, so I'm gonna put another polynomial on the board. Okay, so there's characteristics of polynomials, there's 6. All right, so I'm gonna go ahead and list this, and then we're gonna work through one of these together. So first thing, of course, highest exponent is the degree, we already did that. All right, the next thing, the domain is always all real. Domain is always all real. So if it's a polynomial, you know its domain is all real. It never has, there's never anything that you can't plug in. The third thing that goes with it is the graphs are everywhere continuous. Means that there's no breaks in the graph. No breaks in the graph. Okay. So the graphs don't have any breaks or any openings. The next thing, there's 6 characteristics. They have smooth turns. No sharp turns. So I would write as I write. Everything I put on the board, I would be putting in my notes. Because I see some of you, your pencil is not moving. Do what you want, I mean, but I'm just giving you advice. As the teacher writes it down, I would write it down. All right, next one. An nth degree polynomial has at most n minus 1. So they're called turning points. I call them hills and valleys. So we'll look at what I'm talking about in just a second. So an nth degree polynomial has at most n minus 1 turning points. So we'll see what that means in just a second. Let's fill in the number. Let's say it's a 3rd degree. A 3rd degree polynomial will have at most 2 turning points, and we'll show you that with the calculator in just a second. We'll look at part 5. Part 6, I don't really think you need this one right now, but we're going to go ahead and put it an nth degree polynomial. Has n complex solutions. I don't think we won't need this right now. There's a lot going on with that, but that's just a property that you use. You don't need it, won't use it yet. But we may need it down the road, so just go ahead and put it. Okay, so I'm gonna leave these characteristics here, and we're gonna see if the polynomial that I put on the board shares these characteristics. So let's do, we'll call this one example 2. Given y equals negative x cubed plus 9x squared. All right, so here's what I want, nope, plus 9x, sorry. Here's what I want you to do, part A. Graph on the TI 83, 84, whatever you got. Okay. 2. How many turning points or hills and valleys do you see? Those are called hills and they're technically turning points, but you'll see they have another name. So how many turning points do you see? All right, so graph this one under TI. Look, it's, negative x cubed plus 9x. So graph that one on your calculator, and let's have a look at it and see if it matches to all of this stuff. Where? How many turning points, hills and valleys? They're technically called turning points, but we'll call them other things here in a second. So, before you're gonna graph this on your calculator, but before you even graph, what's it gonna do when it goes left? No, up. Odd and negative goes up. Right, it goes where? Down. What's that called? In behavior. That's the first thing we did today. So we've already done the in behavior. I put all those 4 criteria there. Okay. All right, now let's fill it in. What does the graph look like? Have you graphed it? Can anybody finger draw it? All right, so, right, it goes like this, but can you be more specific? It crosses the x-axis somewhere. Where does it look like it crosses the x? -3, where else? The origin, where else? That's right, that's where it does. Those are called the what? X-intercept. So it goes here, turns around, and crosses. Okay. So let's look at this statement here. Number 5. What is this saying? So I want to make sure that we're clear. If I have a 3rd degree polynomial, the most it can have is 2 hills and valleys. It cannot have any more than that, okay? So notice it has 1 valley, 1 hill, which is a total of 2. So whatever the degree is, if you take 1 less than that, that's the most it can have, okay? So now you could have none because just a regular x cubed graph doesn't have any hills and valleys. It just does that. It has 0. But the most it could have, if it's a 3rd degree, is how much? 2. 1 less than the degree. So if I drew this on the board, I want to make sure you understand statement 5. You should know the degree and the minimum degree it could be. What is at least what degree does it have to be? Very good. 1, 2, 3, 4, 5. It has to at least be an x to the 6th. What else could it be? Yeah, that's right. Could be because it has at most. At most, that one's going to have some. How do you know it's even? Up. How do you know it's positive in front? because it's up, yeah. That's right, that tells you the degree and it tells you whether it's positive or negative. Okay, see how we're tying these things together? So you're gonna get a question like that, it'll have matching, it'll have like 4 choices. And you'll look for the one that maybe has like an x to the 6 plus some stuff. They'll try to throw you off with other things. Okay, now, so do you know how to find these on your calculator? Are you able to just look? What if you can't really tell? You know how to find the x-intercepts on your calculator. So how do you do it, Hank? Like let's say you can't eyeball it, but you want to find it with your calculator. What is it you press?
Second trace.
So just to make sure we're clear, to find your x-intercepts, you hit second trace, then what do you pick?
5 for intercept.
Yeah, I don't pick that one. I do it because that says intersection, not intercept.
Is it 0?
You want to pick 0. All right, you pick 0. And then it's going to take you back to the graph and it's going to say go to the left and go to the right. And you hit enter each time. And then it's going to say guess and you hit enter and it will find it. So second trace, select 0. And it will take you to the graph and you got to go basically pick a point to the left and pick a point to the right and it will tell you the exact location. Okay? So it's a handy feature. Okay. But you should, a lot of them you should be able to eyeball. Okay? Question? No? Okay. All right. What next? Okay. Now, the other thing, so let's look at this. So we've done end behavior, I've listed the characteristics, we've talked about x-intercepts. Now let's talk about extrema. What are extrema? Well, extrema is the plural word for this hilltop and this valley. So hilltop and valley are not very mathematical. Does anybody know the math word for a hilltop? Maximum. Does anybody know the math word for a valley? But they're either called relative max and min or absolute max and min. So I'll differentiate between the two. So this is a relative maximum. So let me explain why we use the word relative. Relative to this little region right here, there's a highest point. But it is not the highest point for the whole graph. Why would I say that? Yeah, it goes up forever. And there is no highest point because it just keeps going. So for this graph, a relative max is just like a little hilltop right here. So we want to be able to find that. You go to the same menu that you did for 0 to get this. So if you want to find the relative max, let me erase my my characteristics here because I'm running out of room. So, hey Matt, boss, what's up, man?
Arithmetic sequence.
Arithmetic sequence, yes.
Well, the 50th term, again, the 3rd and the 4th term.
Yeah.
13 and 18 is the third one, and the difference is 5. Between 13 and 18. How do I find the 50th term?
A sub n is A1 plus n minus 1 times d.
Yep.
So if you don't know
the first one.
maybe we could work backwards
That's
to
what I
it.
was doing.
Yeah.
Is that what I do?
You could do that, yeah. I would do that, and then you just plug in your 50th and get the common difference.
Okay. Now, if the difference between the 3rd and the 4th is 5,
We work backwards 5 to go back to the first. Yes, sir. You got it, bud. So where was I? Let's see. All right, so on the calculator, if you want to find this point right here. So we found that there were 2 turning points. Now, let's find the relative max. So to get the relative max or min, second, you go to the same place, second trace. But this time, what do you think you're going to pick if you want to find the maximum? What's the menu say?
3 for minimum, 4 for maximum.
So you're going to look at number 4, it's maximum. Then once you hit enter, it's going to ask you a couple questions. It's going to say left bound. So you got to kind of tell where the calculator where to look. You go a little bit to the left, hit enter. You go a little bit to the right, because it's going to say right bound, hit enter. Then it's going to say yes, so it's going to say left bound, sorry. So you go left of where you think it is and hit enter. Then it's gonna say right bound. You go right of where you think it is and say, hit enter. Then it's gonna say guess. I don't wanna guess, that's why I'm using the calculator. Just hit enter after each one of these, okay? And then it should tell you. So what does it tell us is our maximum?
X is 1.73 and Y is 10.39.
All right, so now you know the relative max for this one. So if we wanted to find it. So the relative max, what'd you say is 1.73, 10 point what?
39.
All right, now see if you can find the relative min. I'm done, I got it. I don't need a calculator. Check my work, see if I'm in it. But how did I know that? Right or not? Check his work. Make sure, I would all be doing, has everybody tried this on their own? You understand what you're doing? Did you get these answers? Yes? 1.73, 10.39? Well, we should all be, Maria, what did you get? Same answers. Okay, very good. So I knew this because if all the exponents are odd, it's an odd function. That's the characteristic that you have 1 point, you just negate both, and that's the other point. Just a little trick. Okay. So do you see how to find the x-intercepts and the hills and valleys? Now, what do you think is the difference between a relative max or an absolute max and maximum? What do you think is the difference between a relative max and an absolute max? Go ahead.
With relative maxes, there's a high, it's only maximum for that point, there's a higher point, but for the absolute, it is the tallest point on the graph.
So can you think of a graph that would have an absolute maximum? What's that? It can't be at infinity because you can never, there's always something higher. So it won't be a point at infinity because you can't find that point. Can you think of a picture that has a hilltop, that hilltop is the highest point? Yes? Yeah, parabola that opens out. Down. So in this case, let's say you just had y equals negative x squared. Well, what point is that right there? 0, 0. And that would be an absolute max. Why is that? Because it is the highest point. So it's technically both. You can call it relative, but it's also an absolute max. So if we use the word absolute, it is the highest point for the entire graph. And then of course, min, we use the word absolute min. The lowest point for the entire graph. Okay, so let's see if you're able to accomplish the goal. Here's the goal. I got a couple of questions. Well, real quick, what's the degree of the of this? What's the degree of your goal?
4.
Right, and what is the highest exponent for your goal problem? 4th degree polynomial. Now, this is considered the A term. So if you see in the homework, it's asked you about A positive or A negative. So here you can see A is less than 0. That should tell you something about the end behavior. So go ahead and get the end behavior. Use your calculator to see if there's relative or absolute maxes and mins, find those, and find the x-intercepts, and then let's all check our answers and make sure we got it right, okay? You're gonna do that one together. Work together with your calculators. Check your work. Take a couple minutes and do that one. Probably what we'll do after we do this, we'll just stop right here. I'll open the homework. You'll be able to get most of it done. We'll finish it on Wednesday. Because Wednesday we're back here, right? Odd Wednesdays. Finish it on Wednesday. And we'll do rate of change and piecewise on Wednesday. Rather just get all this done first. If I don't have a calculator and I have a phone, you go to Desmos, you can download the Desmos app and it will graph these for you. That way you're not sitting there imagining what the picture is. It's like a green, it'll be a green, green icon. It's pretty useful. I'm sure it's in your cloud. And again, you might have a matching problem where it wants you to match it to a picture, or it might ask you to list all of these. So make sure for the extrema, give the points, and then for the x-intercepts, list them as coordinates, you know, something comma 0, because the x-intercept is y is 0. All right, so I'm at least going to draw what you should see on your calculator. You should see that, right? McDonald's graph. Okay. So what's the end behavior? So, you know, it's going to be as x goes to negative infinity, or as x goes to infinity, what do the y's do? They go to negative infinity, right? Because it's going down. We'll see how it asks you to answer that. I'm sure it'll give you choices. I don't think you have to type in infinity. You just need to have the knowledge to say, this is x, right is x goes to infinity, down is y goes to negative infinity. Okay? All right. What did you, so how many turning points are there? 3. Is that the maximum that there could be?
No.
Yes.
Yes.
The fourth degree polynomial has at most 3 turning points. 1, 2, 3. That's the most it can have. All right, what did you, this point's easy. What's this point right here?
0, 0.
What is this point called? Yeah, but in terms of the questions that we're asking, it has 2 names. It's a relative minimum and it's an x-intercept. So it's an answer for B and it's an answer for C. So in part B, I know that there's a relative min at 0, 0. All right, now, these 2 points here, are they relative maxes or absolute maxes? Absolute, that's exactly right. Nothing's higher than that. And you just give both of them because they're the same. And what did you get for the absolute max? Yeah, I wouldn't round it so much. Just round it to 2 decimals. Not 1.
1.41.
What's that, 1 point?
Or 1.41.
Yeah, you're doing something wrong. I can tell you 1.5 will get counted wrong. 1.41 and what's the y? 4, and then it's negative 1.414. Okay? You gotta list both of those. Make sure you're using the trace feature like I showed you.
I did second place and you,
And it's giving you 1.5.
no, 3.
No, that's not right. You're not doing what you're supposed to do. Go back to y equals.
All good? No, yes, second trade, pick max, no, go back, you're not picking the right thing. Pick maximum, 4. Yeah? Right, go left, go to the left. Press stop, just a little bit to the left, go right, go back, right. Just go a little to the side, enter, that's fine. Now go right of it. Push arrow till you go right of the top. Keep going. Now, hit enter. Yes, hit enter. You're gonna go through that.
You're just going to the first stop. You're gonna go through all 3.
No.
Okay, x-intercepts. All right, so there we go. So you have 2 absolute maxes, you've got a relative min, now the x-intercept. So we got one of them, 0, 0. What are the other 2? Anybody, what did you get?
Negative 2, 0.
Negative 2, 0, and
2,
2,
0.
0. That's what you should have got. Okay, how do you find x-intercepts again? I use that trace feature, I go left, I go right, yes. You can't just go to the first spot, it tells you, you gotta go left and right of where you think that is. Okay. All right. So practice this between, this will be open, of course, you've got like a quiz and things like that that are open still. You need to get those finished. We'll finish this lesson on Wednesday. We'll do rate of change and piecewise on Wednesday. So I'm gonna stop this here.